Hello everyone. The title of this video is Using the Square Root Property. Every exercise I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 2.5, titled Quadratic Equations, and I'm working under the objective heading Using the Square Root Property. So each example I'm going to do is taken from either the examples throughout the reading or from the try it problems throughout the reading, or from some of the exercises at the end of the section that are related to this particular objective. I would ask that every time I bring up a new example that you pause the video and try to work on it and figure it out yourself first before watching me doing it and then comparing, because I think you should be practicing these things as well and not just watching me do them. Okay, so all my examples are written out on paper. Like I said, we're using the square root property to solve these quadratic equations given to us here. And that's the instructions, right? Solve the quadratic equation by using the square root property. Right? So first, let's talk about what is this square root property off to the side here before I get into example 1. Alright, so this square root property, it really only applies to equations where you can get the equation in the following form. So if you have some expression, and I'll use just a big X here. Please understand that this doesn't have to be the variable X. It can be any variable expression. Squared equals, and then over here just the letter K, where K is a non-zero constant. If X squared equals K, where K is a non-zero real number, then there are going to be two, basically if X squared equals K, then X, right, or whatever this expression is that's being squared, X can be one of the square roots of K. Remember, every non-zero number, every non-zero real number has two square roots, a principal square root and then the opposite of that. So we have two possibilities here. We have this expression X could either be the principal square root of K, and remember that's what this symbol represents, right? The principal square root, the non-negative one. Or this expression being squared, right, this X, could be the opposite, pardon me, the opposite of that principal square root, or the negative square root of K. Right? And that's it. Right? So what we're going to want to try to do with all these equations is get the equation, in this form, where we have, a variable expression squared you have a variable expression squared on one side, isolated, right? Notice there's nothing multiplied by it. It's not divided by anything. You're not adding anything to it, subtracting anything to it. It's the square isolated. And then on the other side, I already mentioned k is a non-zero real number, but it is a constant. Right? Meaning that there are no variables on the other side, right? Just a number, a real number. This is the square root property. Right? So we get the equation in this form: variable expression squared equals constant, and then basically say, well, then that variable expression must either be the principal square root of that constant, or the negative or opposite of the principal square root of that constant. Now, if k is positive, right, if this constant is a positive real number, well, then these two numbers here, the square root of k and the opposite of the square root of k, would be real. Right? The equation has two real solutions. If k is negative, if I get a square equal to a negative number, if k is a negative real number less than 0, well, then you'll have the square root of a negative number here, and then its opposite here. Now remember, the square root of a negative number we're going to rewrite with that imaginary unit I, right? It's an imaginary number. So in this case, if k is negative for this square root property, the equation will have, I'll say, two complex solutions with a non-zero imaginary part. Right? Two complex solutions with a non-zero imaginary part. Right, so basically, when I say with a non-zero imaginary part, that just means that the I will show up in the solutions, that imaginary unit I. Now, I know I said that k was a non-zero real number. The reason I said that is because of this. If we have x squared equal to 0, and this is kind of a separate thing, the only number that square is 0 is 0. Right, so if x squared equals 0, then that variable expression must be 0, and that's it. You're only going to get one solution out of that kind of an equation. Alright, so that's enough of that. I'm going to keep referring back to this, of course. Alright, so my example first, right? Example 1. See, this equation is already in the form that I want, right? I have this variable expression x squared on one side, and it's isolated, right? There's, again, not times anything, not divided by anything, no adding anything, no subtracting anything, right? It's just the square by itself equals a constant, right? In this case, it's positive 8. So by the square root property, so I'm going to abbreviate the square root property SRP for the rest of the video, square root property. So by the square root property, this expression being squared, right, x is either going to be the principal square root of 8, right, the positive square root of 8, or x is the opposite of that, right, negative square root of 8, because when you square a negative, you also get you would also get positive 8. And then we, of course, simplify radicals, right? So, x equals the square root of 8, remember, is the square root of 4 times the square root of 2, which is 2 times the square root of 2, right? Or x equals, the opposite of this is also is a square root of 8, negative 2 times the square root of 2. And of course, check them. Now these are very simple, right? When I square this number, it would just give me 8. So you'd have 8 equals 8. Right, so that works. Right, I'll box it in. Right, maybe I should write the word. Don't forget to check solutions, right? You should always be doing that with equations, right? Check them back in the original equation. And when I plug this number in, negative 2 times the square root of 2, or negative square root of 8, when you square it, it'll be positive 8. You'd have 8 equals 8, right? It's a pretty easy one to check. All right, so both of those work. You might also see the following. They might say that the solution set for the equation, right? You'll see the solution set for an equation or an inequality come up quite often. The solution set is just the set of the numbers that make the statement true, right? The numbers for x that work in the original equation. So negative 2 times the square root of 2 and positive 2 times the square root of 2, right? So this is equally valid, right? To talk about the solution set, right? Also, another way you might see these solutions written out, because they're basically the same, but just with a different sign, right? One is a positive and the other one's negative. But other than that sign, they're the same, basically the same number, right? It's 2 times the square root of 2, but just one positive, one negative. So very often you might see people consolidate their answers like this, say x equals positive or negative, right? And then 2 times the square root of 2. And again, this is just as valid as saying each one separately. All right, so if you ever see this plus or minus symbol, it's one solution with the plus or one solution with the minus, right? This represents two different solutions. Please understand what the plus or minus symbol means, and I'm sure you've seen it at some point before. All right, and then if you'd like, I know I checked it out loud, but we can check some of these. This one's a simple one, but you can always check your solutions with technology if you wish. Nothing wrong with that. So I'm pulling up here, I have a TI-84 Plus emulator. So let me show you how I would check these solutions. So I'm going to put in my first number, right? The first number, I want to check the 2 times the square root of 2. Right, or the square root of 8, right? And I'm getting this number, and what I would like to do is I'm going to store it as a variable. I'm going to hit the store button, store it as x. Right, so now every time I hit the x button, it is this number. It is 2 times the square root of 2. Right? So I'm going to clear this now. Right? Every time I hit x, it's 2 times the square root of 2. I'm going to go back to the original equation and enter both sides. Well, the right side I don't need to enter. It doesn't have a variable. So I'm just going to enter the left expression. Right? What's x squared? Now again, when you see x now, it is 2 times the square root of 2. And hopefully I get 8 when I hit enter. And look at that, we have x squared equals 8. And then I can do the same thing for negative, 2 times the square root of 2, right? The other solution I got. And I'll store this number as x. Alright, so now when I hit x, it is the number negative 2 square root of 2. And let me do x squared, right? Do the left side of the equation and see, oh, we get 8 again. So both solutions, both numbers work. right, back in the original equation. And I'll do this with some other equations as well. I'll pull the calculator up and we'll enter a possible solution, store it as x, store it as a variable, and then plug it into our original equation and see if we get a true statement. Okay, so the next example. Now, this is 4x squared plus 1 equals 7. Again, my first step, if it's possible, right? If there was another x term, like x to the first term, I wouldn't be able to do this, right? The only way we're going to be able to use the square root property is if the only expression with a variable has a square and nothing else, no other powers of that variable. But I want to get it in this form first, right? I want the variable expression squared on its own, and then a number, right, a constant on the other side. So this x squared, right, I want to, isolate this, get it on its own side. So first I would subtract 1, right, get that 1 out of there. So we have 4 times the square, 4 times x squared equals 6, right, 7 minus 1. And then divide both sides by 4, right, to get the square alone. Now 6 divided by 4, that reduces to 3 halves, or 1.5 if you want to write that. And now I have an equation that's in the form that I want, right, in order to be able to use this square root property. A variable expression squared equals a constant. Alright, and then by the square root property, right, by the SRP, x, right, the expression being squared, must be either the positive square root of 3 halves or the opposite of that, right, or x equals negative, the negative square root of 3 halves. Now, of course, we're going to be asked to rationalize denominators in most of our exercises. See, there's a denominator inside a root, and that's usually not acceptable. I mean, this is totally fine. I mean, these are the solutions. Okay, nothing wrong with these. Just you may recall that, like I said, most texts will have you rationalizing denominators. So like the square root of 3 halves, and I can rewrite using the quotient property for radicals. That's the square root of 3 divided by the square root of 2, and then to rationalize the denominator, I multiply the numerator and denominator by the square root of 2. And so I'm getting in the numerator, using the product property for radicals, right? These are both real numbers. You can apply the product property. That'd be the square root of 3 times 2, the square root of 6, divided by, and then down here I'd have the square root of 4, and the principal, the positive square root of 4 is 2. And again, they're calling this denominator here rationalized. This may ring a bell from a previous algebra course. The denominator doesn't have a radical in it anymore. So that's how I'm going to express my solutions, right? X equals the positive square root of 6, and then divided by 2. And again, make sure this divided by 2 is not in the square root anymore. Or x equals negative square root of 3 halves, but that's simplified or rationalized to be the square root of 6 divided by 2. Now, if you were to check these, right, don't forget to check your solutions. Either one of these numbers, when you square them, would give me 3 halves. So for either one of these numbers, I'd have 4 times 3 halves, which would be 6, plus 1 would be 7. Both of these would give me 7 equals 7 back in the original equation. Right? So they both work. And then once again, I'll show you how I would check things on a calculator if I really needed to, right? I kind of did it out loud here. But yeah, just enter one of these. Now I'll just do one of them. So how about that positive square root of 6? Right, then get out of there and divide by 2. And I'm going to store this as x, right, as a variable. So now, just to double check, whenever I hit x, it's this 1.224744871, right? The square root of 6 divided by 2. And then I go back to the original equation and I'll enter the expression on the left side. We have 4 times x squared, then plus 1, right? And hopefully I get 7. And look at that, I do. So the square root of 6, divided by 2 is a valid solution. And you can do the same with negative square root of 6 divided by 2. And also, since they're the same except for this sign, you can say that x equals, plus or minus the square root of 6 divided by 2. But me personally, I like writing them separately, just so I know, hey, there are 2 solutions here. Okay, wonderful. All right, so again, doing this same thing every time, same steps. All right, so example 3. I've got another equation where the only variable I see is in a square. All right, x minus 4, that variable expression is in a square. And if that's the case, right, if the only variable expression you see is in a square, then you should be able to solve the equation through use of the square root property. But, right, the first step is to isolate that square. Right, get it on its own side. So this times 3 I need to get rid of. Right, so I'm going to divide both sides by 3. So we have the square, right, the x minus 4 to the second power, right, we have the variable expression squared on one side, equals, and then 15 divided by 3 is positive 5 on the other. And now I can apply the square root property, right, because again I have a variable expression squared on one side and a number, a constant, on the other. Alright, so by the square root property, again I'm just calling it SRP, this variable expression, this x minus 4, right, must either be the positive square root of 5 or the principal square root of 5, or, again this expression being squared, x minus 4, it could also be the opposite of that, right, negative square root of 5. Alright, but now I have a little extra to do. Right, the first 2 examples we had just x being squared, and once I applied the square root property I had my solutions. X was already alone. But now I need to solve these, right? These don't have x alone, right? And all I would need to do in both cases is add 4. So we have x equals, now you can put the square root of 5 plus 4 afterwards. I personally like throwing the rational numbers in front of irrational numbers, right? I like putting non-radical terms in front of radical terms. So this is just a personal preference for me. So I'm adding 4, so I have positive 4, and then you have this positive square root of 5 after. And there we go. There's one, again, possible solution. I will check it in a second. Or, then here if I add 4, we have x equals, and adding 4 gives me positive 4 on the right. And then you have this minus the square root of 5 term. And once again, you could also put them together and say x equals, 4 plus or minus the square root of 5, right? And this means both of these, right? this line here, one with the plus, one with the minus. It's both of these. And don't forget to check. Again, you can check it by hand, check it mentally, just make sure that the original equation is a true statement. Now when you plug in 4 plus the square root of 5 for x, 4 plus the square root of 5 minus 4 would just be the square root of 5. And then the square root of 5 squared would be 5. 3 times 5 is 15. That totally works. All right, and the same thing would happen with 4 minus the square root of 5, right? You plug it in for x, you'd subtract the 4, so you'd have minus square root of 5, negative square root of 5. But then when you square that, that's 5, and 3 times 5 is 15, right? This also works. Or if you'd like to use technology, let me pull up the calculator I had again earlier. And again, I'll just test it with this first number. We have 4 minus the square root of 5, and I'm going to store this number as x, right? So now x is going to be 1.763 blah blah blah, right? X represents 4, oops, oh, I've typed in 4 minus the square root of 5, right? So I'm testing this number, 4 minus the square root of 5, right? So x represents 4 minus the square root of 5, and then I go back and plug it in to the original equation, right? Now the left side is the only one with a variable, so that's the only one I need to plug in for. Let's punch in the left side. We have 3 times the quantity x minus 4 squared. And hopefully, because x represents 4 minus the square root of 5 here, hopefully I end up with 15. And look at that, you do, right? So that value of x, right, 4 minus the square root of 5, totally works, right? And the same thing should happen for what I originally wanted to do, is 4 plus the square root of 5, but I leave that to you. Okay. All right, next question. All right, so we're back to a pretty simple one. X squared, just x squared equals 49. And again, it's an equation where the variable expression I'm seeing is in a square, and that's the only place I see a variable. So if that's the case, right, you should be able to do this square root property method. And it's already set up the way I want, right? Variable squared is isolated, and then, constant on the other side. So I can apply the square root property right now, right? By the SRP, by square root property. The expression being squared, right, x, is either going to be the positive square root of 49, right, the positive square root of that constant, or x equals, the opposite of that, the negative square root of 49. And then, of course, we're going to have to simplify these. Now, the principal square root of 49 is 7. So we get x equals, positive 7, or x equals the opposite of that, right, negative 7. And both of these work. This is very clear, this one, right? 7 squared is 49. Negative 7 squared is also 49, right? So don't forget to check your solutions. Right? I'll put a little check mark, next to these. I checked them. Right? Great. All right, so I've got just one more page of these. Again, very simple stuff. And we haven't seen a square equal to a negative number, and we're not going to in this video. But I did mention that on the first page. If you ever have a square equal to a negative constant, then your solutions will have the imaginary number I in it, right? But we're not going to see it in this video, but we will see it in a future video, I promise you. Alright, so number 5, and now these last two examples I have, right, very easy in my opinion. I have the variable expression in a square. There's no variables anywhere else, so I can use this. I should be able to use the square root property, and it's set up the way that I want to be able to apply the square root property already. Got my variable expression squared alone on one side, and a constant, 7 on the other. So I can apply the square root property right now, right, by the SRP. This expression being squared, right, x minus 3, is either going to be the principal square root of 7, or x minus 3 is the opposite of that, right, the negative square root of 7. But either way, when you square this number, square that number, you'd get 7. Right? We're looking for numbers that when you square it, give you 7. But I'm not done yet, right? Still have to add 3 to both sides of these equations to get x alone, right? So we get x here equals positive 3, and then you have positive square root of 7, right? 3 plus the square root of 7. That's one possible solution. Or, and then adding 3 here, x equals, positive 3 minus the square root of 7. And again, don't forget, I'll always say this, right? For equation solving, check your solutions. Plug these back into the original equation, and you should end up with 7 equals 7. You'll get here, this one will give you the square root of 7 squared equals 7. That's true. And this one will end up giving you negative square root of 7 squared, which would be positive 7, and both of them work. And again, if you want to consolidate it, you can write x equals 3 plus or minus the square root of 7. Just understand that that means there are two solutions, one with the plus, one with the minus. Wonderful. All right, and finally, one last example. And again, like in example 5, it's already set up the way that I want it to be able to apply the square root property right now. I have my variable expression squared on its own side, and then just a constant on the other side, right? No variables. So I can apply the square root property right now. So by the square root property, this x minus 5 can either be the positive square root of 4, or the principal square root of 4, or the opposite of that. Right, x minus 5 could be the opposite, the negative square root of 4. And of course, the square root of 4 is 2. Right? So we have x minus 5 can either be equal to 2, right? 2 squared is 4, or x minus 5 can be negative 2, right? Because negative 2 squared is also 4. But I'm not done yet, right? X is not alone. Just need to add 5 to both sides here. So if I add 5 to both sides of this, you get 2 plus 5, x equals 7. It's one possible solution. And negative 2 plus 5 is positive 3. And once again, don't forget to check your solutions. Now these should be easy. Plug in 7. 7 minus 5 is 2. 2 squared is 4. This works. 3. 3 minus 5 is negative 2. Negative 2 to the second power is also positive 4, so this works as well. All right, so both solutions are good, 7 and 3. Wonderful. All right. But yeah, so the key to all these were, you can use that square root property if you see a variable inside a square, but no variable anywhere else. All right, everything else is just numbers. Then you isolate that square, right? Get the variable expression squared all by itself, equal to a constant, equal to a number, no variables. And then you apply that square root property and solve, and of course check your solutions at the end, back in the original equation. Wonderful. Right, so I'm hoping that watching me go through these 6 examples here help you in some way when you're asked to solve an equation using the square root property on your own. And thank you very much for watching.